Hey everyone, in this video I'm going to cover file sharing over NFS. I'll stick to keeping it somewhat basic, so consider this a getting started video. I may do a follow-up and get into more advanced NFS configuration in the future. Leave a comment if you're interested in seeing advanced config or if you want to see the Windows side of it. For this demo, I'll be working on a Debian system. To start, we'll install the required package. On Debian, the package is called NFS kernel server. Now that NFS server is installed, I'll start with setting up basic share. So I'll create my test folder and adjust permissions. I'm going to add set GID to make sure that all created items use the NFS group. I'll come back to some details about permissions in a bit. NFS share configurations are managed in etc exports. Here we have some sample configuration to work with. The basic layout is local path followed by the clients that are allowed to access the share. The resource can be a DNS name, IP address, or it can be expressed by providing the network address to allow an entire network. The settings that apply to the share are within parentheses. I won't be demonstrating wildcard matching here, but it's useful for convenience and reducing clutter in the configuration file. Additionally, net groups can be specified in exports, which I'm not going to get into here. Another matching method, which should not be confused with adding wildcard characters to hostname and IP matches, is applied by using the asterisk itself. This is referred to as the anonymous method, which will allow access from any client. As shown in the example, multiple entries can be added for a share. Note that anything matching multiple entries will follow precedence rules to determine which configuration entry is applied. The man page outlines the precedence rules that are applied, providing a list. The order in which the items appear in that list are used to determine precedence. There are some exceptions to how they apply when a client matches more than one of the same type specification. Check out man exports for details. I'm going to add our test share. In this case, I'm going to add a simple configuration without any additional arguments. With the entry saved to our configuration, there's another step I need to take to make sure the share is available by running the exportfs command. Running the command by itself will show the current exports. Get any output here because we don't have anything currently exported. Can run the command with the -a flag, meaning export all directories. I get a warning here letting me know that some defaults have been applied since I didn't specify any options in the exports file. We'll come back to options in a bit. And so if we make another run of exportfs, now we can see that our NFS test directory is exported. If I add -v, I get the verbose output, and I can see all the options that are currently applied to the exports. I'll run through some of these real quick and make a couple of adjustments to exports. So sync is already set as a default. I'm going to add it to stop exportfs from complaining about it. The quick explanation is that sync is safer. Async can provide better performance. If something happens like a server crash while NFS transactions are in progress, it can result in corruption or data loss. A deeper discussion on when and why you might want to use sync versus async is outside the scope of this video. There are good articles and various forum discussions about it out there if you're interested in learning more. W delay, reply to request only after changes have been committed. No W delay is the inverse of the setting and can be used to improve performance. Setting no W delay doesn't work if the async option is applied. And even though no subtree check is the default, I'm going to explicitly add it for the same reason that I'm going to add sync. Without getting into much detail about exactly what it does, it is related to security. You can read about it in the man page if you'd like. I'm skipping the details here because the section describing subtree checking states that it tends to cause more problems than it's worth, so I'm going to avoid using it. And then the sec equals option here has several settings applied, which are comma delimited. Sys, this is one of the security flavors that can be applied. The sys option means use local user and group IDs to authenticate NFS operations. Multiple flavors can be specified together here and provide various protections for improved security. I'm going to keep it basic and use local IDs for this video. RO, meaning the share is read-only, which May be desirable for some situations. Later, I'm going to change that to read-write to allow write operations. Secure, as stated in the man page, it requires that requests not using GSS originate on an internet port less than 1024. The short explanation, GSS is short for Generic Security Service, which defines an API that Kerberos runs on top of. Kerberos can be used to improve NFS security with improved authentication mechanisms. In this case, the idea is that security is improved because only root can create or activate ports below 1024. Root squash, this means map request from root UID or GID to the anonymous UID and GID on NFS client connections, and we'll talk more about this later. But this has the effect of limiting root's level of access to modify ownership permissions when connected to the share from a client. If no root squash is applied, the root user on any client that can access the NFS shares will have unrestricted rights. The root account on the NFS server will still have the ability to manage files and directories. We have no all squash. This setting allows UIDs and GIDs to map to the user and group versus all squash, which is like root squash, maps the UID and GID to the anonymous user. Again, we're going to take a look at this more later. And here I'm just going to add my base options. And now I'll run exportfs with the -r flag as well as v for verbose. -r means re-export. And so when we include verbose, when we're performing operations to export directories, we get a little bit of feedback on what's going on. And now I no longer get those warnings about any of those defaults being applied. And so let's just check that out here. And we still have all the same settings. Plus, I've added read-write, so it's no longer read-only. So now that we've set the share up, it can be mounted on clients. On the client side, an NFS helper is required, which is already installed on my client. On Debian, that can be installed with nfs-common. And then we have a basic command mount. I'm not using a lot of options here, but our mount command here, the type NFS, and then we have our IP and the path to our share, and then where I want to mount that. So I'm going to mount that to the NFS directory here on the client. And then I can confirm it's mounted by looking for NFS4 mounts. And so here we get a return of those mounts, and then we have the current settings of the mount point. Run through some of these and kind of skip over what we've already discussed. And so here we see rel a time. This is related to file timestamp maintenance, which I'm not going to go into here, as this is moving into tuning that is out of the scope of this video. There's a section in the NFS man page, as well as the mount man page, that explains the details here. The next setting in the list shows the version of NFS. And then we have rsize and wsize options. Very high level explanation here is these values relate to the network transmission size for the NFS request. The values can be adjusted to tune NFS connections, but I'm not going to be getting to tuning details in this video. In this case, I haven't explicitly configured anything, so the value returned on this system is what was negotiated between the client and server. The NFS man page provides the range and increment details, but to demonstrate, I'll go ahead and unmount our share and I'll set the value. Okay, so setting the value with our mount command. And then if I check our mount settings again, we can see that the values haven't changed, so the negotiation is still the same even though we explicitly set it. And so back to our settings here where we left off. Namelen is related to maximum length of file names. Hard NFS client recovery behavior. Hard is the default and is related to retrying an NFS request. Hard will retry indefinitely, while soft will return an error to the application and stop retrying. There's some potential issues with using soft, but you can check out the man page for details on that. Time O defines how long to wait to retry an NFS request. How the setting behaves, well, depending on which version of NFS you're using, it will change because it will behave differently if you're using TCP or UDP. Retrans is the number of times the client retries a request, protocol choice, and using hard or soft influence the way this setting behaves. We also get the client address and then the local lock setting. With a value of none, I'm not going to get into a lot of depth here as far as the NFS internals, but the short explanation is that local locking prevents concurrent editing of a file on the local client. NFS version 4 introduced lease-based file locking built directly into the protocol versus the approach of earlier versions, which handled locking a bit differently. The last value is the IP of the NFS server. So now I'm going to unmount the share, and then I'm going to add it to fstab and mount it that way. So here in fstab, now I have my line to mount this automatically at boot. And I'm just going to go ahead and mount. Now for a quick discussion about permissions, along with the demonstration of a couple things we discussed earlier. I covered SMB sharing in a previous video, demonstrating share configuration that can apply the desired permission and ownership when files and directories are created over an SMB connection. In the case of NFS, it is possible to install the NFS ACL tools to gain a bit more control over share permissions, but I'm not going to cover that here, and instead I'm going to stick to basic permissions. I'll probably cover ACLs in general and NFS ACL tools in a future video. So to start, I'm going to set the share up using an approach that requires matching user and group IDs so that they exist on both the clients and the server. Depending on how the environment is configured, it can present some challenges, but it's not difficult to manage on, say, a small home setup or even in a smaller business type environment. Even in large environments, use something like Ansible or Puppet to manage those IDs. So on the server side, we have our NFS group, and then as far as the user goes, I've set up a user named NFS owner to own files. So I didn't have to set it explicitly to someone named NFS owner. I could have done this a little differently. I've just kind of done it this way for consistency. In the case of how we're doing it, here really the biggest thing is the group that matters in this example. But we'll check out some other stuff about that later. So now let's check out our client. And we have the same group over here with the same ID. And our NFS owner is over here with the same setup. So everything matches, and I've set permissions as 2770 so that the owner and group will have full access, and set GID is applied to make sure that the group ownership will be set to NFS group when users create items on the share. Let's check out our NFS directory over here on the client and on our server. And we can see that that matches up. And also just know that after you mount it, the permissions on the directory are going to change on the client to match the ownership that you have on the server. So the catch here is that permissions are being applied according to the user's umask. The current umask value applied to this user account results in applying read and execute permissions to the group and other users. Users with access to the share will need to manually modify group permissions on files and directories as they create them so that other members have the appropriate access. Because remember, I talked about earlier that I don't have control over the user that owns it. I can't set that to inherit unless I use ACLs. Another option here is to adjust the umask to create directories and files with the desired permissions. Making the change will provide consistent permissions on items within the share. Since this applies to all files and directories created by the user, depending on the environment and circumstances, users may still need to adjust permissions on items created outside of the share. So keep that in mind. Let's check out a couple of other examples of some potential problems users might run into. I'm going to try to write to a file that I created with another user. And I can't write to the file, but I can delete it due to the way permissions are applied to the directory itself. Also, I can't create anything within the directory that the other user created. But I can delete the directory. Again, due to the way the permissions are applied to the parent. So now that I've created things within that directory, if I try to descend into the directory and delete objects within, I get permission denied. And that's because the group itself isn't picking up write permissions, it only has read. Switch over to the other user. And so kind of due to that limitation, that's one of the problems we run into with NFS. Even though we can stick the group to it, we don't have any extra parameters to apply a set of group permissions without using something like ACLs. So as I mentioned, we can get around this by setting the umask. So I could do that with my profile here. And apply the changes. And now with the umask adjusted, items are created with the appropriate permissions. I'm going to revert that real quick and set back to the default mask. So we're currently at all right, and now we're back to the default. Another option is to use all squash, which will apply anonymous access. Depending on the situation, this might be fine, but be aware that the way I'm applying this method, any user on the client system will have full access to the share. And then re-export the share. And since we're mapped to the anonymous ID, now we need to change some ownership over here. If we check over on the client, since they've been updated on the share, they are updated over here. Now over here on a user that never had any access to the share and isn't part of our NFS group, everything is created with nobody, no group, which is what the anonymous ID maps to right now. And so any user can access the share and create items and delete items. Last thing I want to check out is the root squash option that's applied. I'm going to remove the anonymous access and re-export the share. So get rid of our all squash option. Set our permissions back to these owners and re-export our share. And re-export the share. And let's just check out roots rights over here. And I don't have permission to move into the directory. And I don't have any permission to list out properties of the directory. And I cannot take ownership. So this is expected when the root squash option is applied. Clients won't have access when using the root account to make these changes. So let's check out what happens when we add the no root squash option. and export it and re-export it. Now root has full control to act as root typically would when managing things on the local file system. So the purpose of root squashing is to limit root access on remote clients. The catch here is that root can run commands as any user or group. So it's still possible to work around root squash. So a quick recap of the two examples of providing access. The first with groups. Keep in mind that with the group method, using basic permissions will either need to be modified each time files and directories are created on the share, or the umask can be modified. ACLs are another option. This is a bit more advanced, and I'll likely cover that in a future video. The other method, using the all squash setting, allows clients to map the share with anonymous access by mapping to the anonymous UID and GID. This method is a simple approach that allows all users on clients access to the share. There's still additional considerations and some aspects of anonymous access I didn't expand on here. There are also other factors such as centralized authentication, but I'll save that for an advanced NFS video. For now, this should get you started with the basics. So that's it for this video. If you found this helpful, please leave a like and subscribe to the channel. Thanks for watching.